Nikki and Emily are buying tickets to a school play for their families. Nikki buys 3 adult tickets and 1 student ticket for $15. Emily buys 2 adult tickets and 2 student tickets for $14. The coordinate plane shown below displays a graph that models the situation, but the labels for the 2 axes are missing. What does the point of intersection on the coordinate plane represent? Well, let's start by writing our 2 equations. Our first equation is with Nikki. It says Nikki buys 3 adult tickets and 1 student ticket for $15. If we were to write Nikki's equation here, I'm going to write it 2 different ways here. So with Nikki, we have 3 adult, so 3A, plus 1 student, we could just do S or 1S, and it is equal to $15. Now when it comes to coordinate planes, when we have like A's and S's, it's not as favorable. So I do recommend that instead we convert this to X's and Y's underneath it. So 3X plus 1Y, or just Y, equals 15. The second person in our problem is Emily. Emily buys 2 adult tickets and 2 student tickets for $14. So I'm going to first start with the A's and the S's, and then we'll convert it. So Emily had 2 adult, so 2A, plus the 2S for the 2 student, and then that was for $14, or we convert this to X's and Y's, 2X plus 2Y equals 14. Now we should figure out which line is which, and that is done by converting these from standard form to slope-intercept form. So with Nikki here, Nikki's was 3X. Let me just change the color back to green. So 3X plus 1Y equals 15. To convert from standard form into slope-intercept form, we move the X over on the left to the right by subtracting 3X. When I do this, I get the following information. I am left with 1Y, or just Y, equals negative 3X plus 15, because that was a positive 15 up top. Then to get rid of that 1, we can divide everything by 1, but dividing by 1 does not change anything. So now we get Nikki, that equation for Nikki, to be Y equals negative 3X plus 15, which tells us that the y-intercept is 0, 15, with a slope of negative 3 over 1, down 3, right 1. If we examine this here, there is no y-intercept of 15 on this graph because it is limited to just a height of 10. But what that does tell us is the only one that goes off here is this one right here, which we could label as Nikki. By default, that tells us the other one is Emily, but just to make sure, we can convert this one as well. If I convert 2x plus 2y equals 14 into slope-intercept form, Subtract that 2x to both sides, like we did the 3x in the other one. From here, we get the following. We get 2y equals negative 2x plus 14. Divide everything to separate the number from the variable by 2. And what that would give us is the following. I would then have y equals negative 1x plus 7, which would have a y-intercept of 0, 7, with a slope of negative 1 over 1, down 1 and right 1, which was this one right here. Let me refer back to our original question. The question stated, what does the point of intersection on the coordinate plane represent? Well, the point of intersection are where the two lines cross, Emily and Nikki, which is right here. This ordered pair is 4, 3, because it goes right 4 and up 3. We can also now label our x and y axis. Notice from the left side of the problem, our a's were our x's. Therefore, the a's here, or the x-axis, is going to be the cost of adult tickets. And this makes sense because the problem told us the number of tickets, but it never said the cost. And then notice what we changed our s's to. The s's became our y's, which then tells us that the y-axis is going to be the cost of, they are referred to as student tickets. So therefore, if we look at that ordered pair now, the ordered pair was 4, 3. We just labeled what x meant. So x is 4, y is 3, and we label what these mean. Therefore, this is going to be $4 for the adult tickets, and $4 for adult tickets, and $3 for student tickets. If we then refer to the multiple choice options, the one that has this is going to be option D. The price of each adult ticket was $4. The price of each student ticket was $3.